All right, so this was the originally designed mount with rotating platforms, so we could get a good camera calibration for the stereo imaging processing, but did not account for how Florida heat and PLA don't mix well. So you can see one of the mounts is bent. That happened from trying to get some images during the day for about 10 minutes. So we're gonna have to design something different to put our cameras on. So unfortunately, due to the heat failure of the camera mount, we're kind of using this makeshift piece of wood to hold everything together for the midterm demo. But here you can see we have two telephoto lenses consisting of a large 2-inch diameter achromat and a smaller 20 millimeter diameter negative lens in the rear, making 400 millimeter focal length system. But the actual size of the system is only 360 millimeters to make it a little bit smaller. On the back end are manual focusers to allow the two lenses to focus on whatever object we're focusing on, and that's connected directly to our digital USB cameras. So even though the initial plan was to use MATLAB and their stereo camera app to create a calibration file, MATLAB has been constantly timing out on image capture, so it has become unusable despite testing for the past 5-6 days to try and correct the code. So today we switched to OpenCV. Here I have a live stream of a mailbox that's approximately 250 feet away. So in our left camera we've got real good resolution, very clear picture. Right side, I need to adjust the focus position, so I might have to make some modifications to the actual lens housing so I can bring the sensor closer to the rear lens. Even though I have the focuser, we're not getting as good of an image as desired, but with this stereo image we can capture a left and right image of a desired object, and then we can do our disparity calculations, depth measurements, and determine how far away the object is. Again, due to issues with MATLAB and image capture, switched into OpenCV yesterday. So far we've been able to set up code to do a live stream so that we can aim the system and make sure that we are capturing the images we want to capture. Additionally, also have code to be able to live stream and capture images simultaneously in order to create a stereo camera calibration file so that we can hopefully perform the final image processing required to capture image of an object, perform all the depth measurements and disparity, and be able to provide the calculated distance of that object to meet the goals of this project.